LabVIEW offers a variety of data types to work with, and we'll consider data types, or some of the major data types, and then also conversions between those. And I'm creating 3 front panel controls labeled A, B, and C. And those are always defaulting to the double precision floating point. If I select my context menu and pick representation, then I can change that to a long integer. That's a signed integer, by the way. The one underneath here, U8, is an unsigned 8-bit integer. So we can do signed integers and unsigned integers. Now let's try doing some math on these mixed data types. Now we see the little red dot appears there is referred to as a coercion dot, and that says that the signed integer is being promoted to a double before it actually generates, or before the addition is actually calculated, and then we also generate a double as a result. Let's try that again. Now let me try selecting or subtracting the unsigned small, that is the byte, from the larger integer. Again, we see the coercion dot showing up for the smaller of the two. So actually, coercion says you coerce the data type to be matching the larger of the two. So this is generating the signed integer 32 as a result. To take care of take control of the conversion process, you have a whole variety of conversion nodes at your disposal. So instead of kind of relying on the coercion dot to do the job for you, you can take control of it and say, I specifically want this, for example, unsigned 8-bit value to be coerced into a signed 32-bit value before being applied to the subtraction. Now, Boolean is another data type, and it can take on values of either true or false. Sometimes we like to be able to mix these in with numerical indicators as well, or other types of numerical operations. So checking the broken wire, that says that we've got a mismatch in data types. This is a handy one. This says convert the Boolean data type to either a 0 or a 1, and that's an integer as a result. We're seeing the coercion dot showing up. If we turn on the context help and wave it over the wire, it tells us that this is actually a 16-bit integer as a result. So I change the representation of my indicator and the coercion dot disappears.